welcome everyone. It's great to see you.
Welcome everyone. Yeah, it's 6:07. Well, here on Eastern Standard Time. So, a lot of familiar faces, some familiar faces. Brianna, welcome. I know you've been part of the community, but haven't been able to attend class. So, but hello to everybody. Rohan, Rihanna, Logan, great to see you guys. So Joel and I will be co-teaching this class. So we're going to be doing this. This is the Wi-Fi robot build along series. So we're going to do this every other Friday at this hour. And we hope that we'll learn from you. So you're the first group that's going to be doing the Wi-Fi robot. So kudos to you. We still have a ton of other students still doing the Monday, Wednesday classes. And you can still attend those classes. You just have an additional class for Fridays to do the Wi-Fi robot. And you'll still be able to, there'll still be other lessons that you haven't done on Monday, Wednesdays, if you still want to attend those. The Wi-Fi robot is strictly going to be the Wi-Fi robot, and we may occasionally bring in some additional creative projects for you to work on. What we're going to do today is make sure that everybody has the right parts for the Wi-Fi robot. If you are missing anything, let me know, and we can send something out. The way that we plan to do this is we're going to spend the next few weeks building the robot together, and then once we have the robot all built, we're going to do some fun coding lessons to make the robot do different types of things. So some of it might be fun, others might be useful, depending on what you're trying to do. But we'll go from there. And then, of course, these are just regular build-alongs. So if you ever have questions, jump in. Yeah, so why don't we go ahead and get started. So hopefully everybody has their Wi-Fi robot kit. Does anyone not have their Wi-Fi robot kit? If you do, let me know. But I think everyone should. All right, cool.
Wait, is the Wi-Fi robot kit the just robotics kit?
Yeah, on the postcard it says robotics kit 1.
Yeah, I have that.
All right, cool. Yeah, you should be good to go then. Excellent. All right, so today we're going to be doing, so Joel's going to be leading half of the lesson. I'm going to be doing the first half of the lesson to make sure we go all over the parts. But we're going to be going over infrared, which is some of the components that are in the kit use infrared, and we're going to learn how that works to make the robot actually move. And then throughout the middle of the project, we're going to see how it's applied, and then talk a little bit about wheel rotations. And then for the session goal is to prepare you for the assembly. So it'll be a build along, but there may be some things that you do outside of the build along as well, so that next time you can come with some of the robot pieced together. And obviously, if anything comes up between now and then, you can always reach out to us as well. What I'll do too is I'm going to share most of you should have this link. It's the lesson library. So I'm going to share this in the Zoom chat right now. This will send you to our lesson library. So you could essentially build this robot on your own without attending the build along classes. I would view the build along as like a lab. So this is going to be a hands-on lab where you're learning something unique about the robot. And we're also going to be coding it in a variety of ways, as I mentioned earlier. So if everybody wants to go to that link right now, it'll say robotics kit at the top. And then if you click on number 4, the part where it says, what should I have received? You can go ahead and click on that. And we're just going to quickly go over and make sure that everybody has the parts. I don't think anybody's missing anything, but there's a possibility that some of you might be missing a Lego piece, which is what we call them blue wrappers, but it's essentially a blue Lego piece with some screws. So if you are missing that, shoot me a note in the chat and we'll make sure we send something to you straight away. But why don't we go ahead and dig in? So you should have 2 yellow motors in your kit. So this is going to make the wheels turn eventually, powered by the batteries. Doesn't come with batteries, so once you have the robot pieced together, you'll need 5 AA batteries. Or, is that right? No, 6 AA batteries. Cool, and I believe we just got Ariane who joined. Hey Ariane, we're just going over the parts in your Wi-Fi robot kit to make sure everybody has the right parts. But welcome back. All right, you should also have 2 wheels. These are eventually going to go attached to the yellow motors, in addition to the mounts. You should have a circuit board, not quite as big as the Arduino, but it's called an I2C motor driver. All right. You probably got some more cables. Those are also in your creator set, which you can reuse. Those are universal across all of our projects. You got your battery holder. And then you have the main platform for the robot, which is made of acrylic. You can actually peel that brown part off, and what you'll find underneath, it's just clear acrylic. Some of you may have received like a blue acrylic, others may have received just a standard clear acrylic that's covered by this. It's almost like a brown sticker on top of covering. When we print the acrylic pieces, they're actually big sheets, and then we program the laser cutter to cut these as well. If anybody ever wants to see that in action, let me know, if they've never seen a laser cutter in action. You should have 2 motor mounts. Line finder modules.
I've used the line finder modules.
Cool. These ones exactly from the kit?
Yeah, those ones.
Nice. Cool, so you'll see those a little later. And then we got our line finder mounts. When we were packing these kits, we would call these mini elephants because they look like elephants a little bit. Then you got your encoder wheels, which we called the donut when we were packing this kit. And then we have the steel Omni wheel. So this is gonna serve as the 3rd wheel, so to speak, that'll make the Wi-Fi robot move along with the 2 other wheels. And then some hardware screws. Now, the piece that I was referring to earlier that some of you may not have, let me see if I can quickly find it so you can see a picture of it. But it's a blue Lego piece, basically, in a little baggie. Does anyone not have that? If you don't, let me know. You'll also need your Cduino board from the creator set. So that's reusable. We're going to be using that. You're also going to be using the shield where you plug in all the cables. So you'll need that as well. And I believe that it's all when I get to that. But yeah, if you don't have the Lego pieces, let me know. Here we go. Okay, so it's not this specific hardware. It's that yellow encasing. It should be a blue piece just like that. So it's basically where we're going to be putting in the Wi-Fi module, which is another piece that should be on your kit as well, actually. I'm sorry I didn't cover that. But you should also have a Wi-Fi module in your kit. If you don't have that, please let me know as well. It should say it on the component. It should say Wi-Fi module on it. Cool. Any questions so far about any of the pieces?
I don't see a Wi-Fi module.
Okay, cool. So I will send you, is that Logan that said that?
Yeah.
Okay, Logan. Yeah, I'll send you a Wi-Fi module.
Okay.
I don't think you'll be needing it today, so oh, we got one more student joining us. Welcome, Mimi. Welcome, welcome. Hi. You haven't missed much. We just went over all the parts in our kit and just making sure that everybody has all the right parts. I'm going to share a link with you on the Zoom chat as well in case you missed it. But So we just went over all the parts in our kit, and the picture that you see on my screen is what your robot will eventually look like. Some of you may have a blue platform, others you might have a light or a darker acrylic piece as well, which is what the different types of acrylic that we ended up getting when we first made this kit. So, all right, so I'll stop there. Any questions so far? Cool. And Mimi, just in case you missed this too, you'll need your Cduino or your Arduino, and then your shield. Those all should already be put together just from some of the classes you've been in. You'll need your USB cord, obviously, for the programming piece. And also, because you guys are all like pretty amazing students, so if you guys ever have feedback for making these better, let us know. You guys are somewhat of our, you guys are our very first group to do the Wi-Fi robot, so we have close to a couple hundred students, so you guys are like ahead of the gang there, so to speak. All right, so I'll stop there. And again, the lesson library, again, you don't have to wait to build your robot. You can use the lesson library, follow the written instruction to build your robot. And then the point of these build-alongs, it's going to be, again, like a lab to do some fun coding exercises that are not covered in the lesson, like Joel will go over in just a little bit. All right, everyone excited so far? Cool, I know it's Friday. I hope at least some of you have some popcorn or a refreshment next to you. All right, cool.
So I'm going to jump in here with kind of a different topic. So I'm going to take the screen share in just a second here. So, you know, if you've been to build-alongs as part of your experience with Thimble, you know that one of the things that we really strive for is to have some kind of universal concept that is something that you can learn and take away from every single time that you join us, right? So let's just talk a little bit about our sort of universal concept for the day here. I want to find something about this robot that is familiar to you, but at the same time that you can learn something more in depth. And I think that we all know something about light, whether it's something you learned in science class or just the simple fact that we do a lot of things in our lives that revolve around light. It's a relatable, everyday thing. So what do we know about different wavelengths of light? So here's the visible spectrum. And I'm certain there's been a science teacher somewhere in your life who wanted to tell you, by the way, the visible spectrum is a tiny little piece, right? Tiny little piece. And below our visible spectrum is ultraviolet, above our visible spectrum is infrared. In our creator set build-alongs, right, we put a lot of energy into understanding just the visible spectrum, talking about mixing red, green, blue color combinations. Some of you, I recognize some familiar names that I haven't seen some of you since I switched hours that I do build-alongs and things like that, but I recognize some returning faces and I'm thrilled to see you again. But you know, we spent a lot of time talking about, hey, you know, this is how color mixes when it comes to wavelengths of light. And we know there's a lot of interesting stuff there, but there's also a lot of interesting stuff when it comes to infrared and also ultraviolet, but we're focused on infrared here. But it does help to know that there are different chunks of the visible spectrum, right? So anybody out there, before I jump in too much about this, anybody out there have any familiarity with ways we use ultraviolet and ways that we use infrared? Just tell me things you know about them. Like, are UV rays good for you or bad for you? I see a thumbs down, right? Right? UV rays certainly are, you know, why our skin changes color in excessive sunlight. We get a lot of sun, right? Yeah, tanning beds rely on ultraviolet waves. So let's go ahead and put some stuff up on the board here, right? I'm going to use the text box feature because I don't think I have the speed to write with my computer mouse that well. All right, so UV rays in tanning beds. What's another use of UV ray? Anybody else? Oh, night vision goggles use infrared. It's like you read where I'm going to go with one of my later slides. How did you know that? Good job for you for knowing that. Night vision uses infrared. So So, all right, how about this one? X-ray. I actually don't know what X-rays are in the light spectrum. Let me see if they were they on this? Oh, they're below ultraviolet. Boy, glad I had that chart. So, all right. All right, what about this one? Anybody out there into there's a material called resin that is used by certain 3D printers that when you're done 3D printing it, the typical solution is to leave your 3D prints out in the sun so that the plastic will properly harden. It's an ultraviolet curing process for liquid resin. Is anybody out there familiar with this? Do I have any 3D printing enthusiasts? I am a mega huge 3D printing nerd. Like, that's about, if I had to describe what my, like probably biggest hobby project is, this 3D printing. That's where the majority of my energy goes. And UV rays are actually used in 3D printing. So UV resin for 3D printing, it's a big thing. What about infrared? What else uses infrared? Anybody have any other thoughts other than, by the way, Rowan, great job knowing night vision uses infrared.
Thermometers.
Thermometers? I think you're right. There's something out there, right? That's like
it's the one that they use to like the little gun thermometer. Where it shoots the red beam light onto your forehead.
Okay, so we're gonna call it medical devices, all right? What else we got out there? I think you are right that there might be an electrical heater, heat generation. I think there is some kind of system out there for IR-based heat. I didn't like come here expecting I knew every use of IR, right? For me, you know what the big one is? That like I'm sitting here going like, wow, I'm really surprised that like nobody pointed out like television remotes. Because that's like the easy one, right? Like in my head, I'm like, come on, like this one's everywhere, right? I don't know, Rowan. I never saw an invisible ink pen light. Is that, it wouldn't be IR if it's the light that you can see as a human though, right? So, do phones use IR? Security devices, things like that, yeah, okay. Security devices, right? If it's got a, broadcast infrared to then pick up with a night vision camera, right? That's a common solution. Boy, infrared's in a lot of stuff, isn't it, right? Anybody out there have any video game system that you think uses infrared? There's a big one. If you don't know it, I'll tell you at the end today. So the Switch might have something infrared related, but it's actually the previous generation, the Wii and the Wii U, that the Nintendo Wii sensor bar blanketed your living room in infrared. Like, that whole little system is just a big giant infrared like blast happening in your living room, right? And fortunately, infrared is not like UV rays, right? If I had a device that blanketed your living room with UV, you would end up with some skin problems, right? It wouldn't be healthy for you, right? That's why we wear sunscreen when we're in UV light. So is that somebody's UV related product you got there? Here, you can talk on the mic. What you got there?
It's a 3D printer pen.
Oh, it's a 3D pen. Yeah, I love that kind of stuff. So if you ever want to talk 3D printing stuff, as we're, like I said, doing the warm up, getting settled in, you'll find me ready to talk about just about anything 3D printing anytime. I got a 3D printer pen too. I love that kind of stuff. All right, so we got some ideas. We know some things about different types of light. Great. Okay. Well, what I want to show you today is actually how easily hacked these things really are, right? So here I have a demo for you. I want to talk about television, how televisions use infrared sensors. So how many out there, anybody want to give me a little wave in the video or give me a emoticon or tell me in the chat, you got any siblings? I had an older brother, right? And what do you do whenever your sibling doesn't want to watch whatever you want to put on the TV, right? You've done this. If you have a sister, if you have a brother, whoever's out there, you know, right? Some part of that, yeah, cover the infrared light on the remote or cover the sensor on the TV. So it's like you're watching the channel you want to see, right? And they're trying to change the channel. And so you run over and you cover the receiver. You've done this, right? We used to also have these things. They're ancient. They're called VCRs. And those also had little infrared receivers. They had like a second remote.
Computer.
What was that?
Use my computer.
Oh. But yeah, so my story to you is, right, why are we able to, whenever somebody wants to change the channel, if we go and cover the little sensor at the, sometimes my son, who's 3 years old, will leave a toy in front of the infrared receiver on our television, and then I have to decide how badly I want to watch TV or if I just want to read things on my phone when I sit down on the couch at night after he's gone to sleep and I don't want to stand back up and there's like a dinosaur blocking the infrared receiver of my television and I can't turn it on, right? Sometimes I have to convince myself that I wasn't interested in watching TV anyways. But we use infrared to send a signal to tell our TV to turn on and also to change channels. How many of you have ever had to program a TV remote? I feel like I do this for my mom like once a month. It feels like it's far less frequent than that, but every time she always has me do that, where you open up the manual, you figure out how to, get to the menu, you enter the code so you can make your, in my town, we have Comcast for our cable provider, but you make the cable TV remote work with the regular television and you have to program it in, right? What are you programming? You're programming the, basically numeric value that matches when you hit up on the volume, that it's going to match up on the TV. When you hit down on the volume, it's going to match down on the TV. So Mimi, I don't mean to leave you out on a cable TV example here, but I think you would be able to guess the idea, right? That it's got a receiver and the remote blasts infrared light.
Is the cable a Sony? What is it?
Cable what?
Can a cable be a Sony?
Like, I'm just talking like the subscription television package is all I'm talking about.
Oh, well, then I don't have that. I just have TV.
Yeah.
On my computer.
Hey, I stopped paying for cable years ago and we just stream Netflix and Hulu and stuff, but whatever the case may be, that's what I'm saying. Sometimes you have to program like universal remotes so that it works with the cable box, it works with the TV, that's all. So what are these codes that go into remotes, right? There are actual numeric values being blasted by your remote to the TV. And some of you mentioned another use of infrared, which was infrared goggles, right? As a probably like 13, 14, 15-year-old, I was like fascinated by infrared goggles because of video games where, like the soldier character would be, wearing night vision goggles and the whole screen would turn kind of that greenish, color, right? And what does it do? Yeah. How'd you know that, Charlie? So, you made the right guess there of what video game franchise would have been around whenever I was a teenager. So anyways, you pop on that, set of night vision goggles and everything's got this green tint you're able to see in the dark. Well, what's really happening is infrared light's bounced off of the surface of things just like regular light, and we pick it up with our eyes when it comes to regular light. With night vision goggles, a sensor can detect that infrared light. So what are the two takeaways here? Okay, infrared goggles, television. Infrared goggles, television. Okay. So an electronic device such as a TV remote, I'm gonna go ahead and turn off my slide share. Okay. An electronic device such as a TV remote, hope you can see me. If not, you can double click on my icon and I'll become the focus for you if you see other people. A device like a remote can broadcast infrared, right? And devices such as televisions, such as night vision security cameras, night vision goggles, they can detect infrared. Now, the same is true with sound, right? That we have sound waves that we can produce and detect with electronic devices that the human ear doesn't pick up. This is not exclusive to light, but we're interested in the details about light because you can't make a robot that has a strobe light flashing that is like lighting up the room, right? We can't use visible light with a robot and make a good experience for people to interact with it. It would actually be kind of distracting, right? And could potentially, if it was like, blinking as fast as what infrared light sensor needs to. It could do some damage to some people, really be disorienting, right? So I'm sharing with you this idea of infrared light, gives us the ability to do something without anybody seeing the communication, right? So I've made a little demo here today to show you, if you have a TV remote lying around, right, there are different DIY electronic devices, right, that have built-in infrared. Anybody know what this device is, by the way? Is anybody familiar with this little unit? Have you seen these before? It's not a thimble thing that we do. It's just something that I have a tendency to buy every single development board on the market. I got like I like to joke that I'm into board games when I really just mean electronic boards. But anyways, maybe it's not as clever as I think. Anybody familiar with this little device? Let me see if we can put it in the chat. Nope, nobody recognizes it. Okay, it's actually called the Circuit Playground. So the name is on the back here. It's sold by Adafruit. If you've ever shopped their website, pretty neat company. So this device of theirs, let me go ahead and turn it off real quick. It has a ring of lights, all right? And here, okay, I don't have a third hand to like interface with my computer, right? I am literally pushing numbers, right, on my remote here. That's green. There we go. Kind of a bluish color, different blue. Got a nice magenta here. Last one's white and then off, right? And here I'm going to do red for a second. And, one of the things that's really kind of interesting, right, is just like volume goes up and down for sound, right? I'm going to do volume. Watch the glow off my desk. See the intensity of the glow is growing. The sort of orb of red light there is getting bigger. Let me go ahead and start turning it down. Right, you might see it go the other way. Yeah, so I made volume correspond to brightness of the lights. And boy, this thing's like flashlight bright if you really crank it up. So I turned it actually all the way down. You can't see it anymore. There we go. That's like the lowest brightness setting. Yes, hand up. Let's see here. Is it Mimi? Go ahead, talk to me.
If you unplug it and like stick it onto your wall somehow, will it kind of like be a room light?
Right. So if I just power it by any source, so if I just, I've uploaded the code to this. This is running off the USB power of my computer, right? It has a regular power plug for a lithium-ion battery, right? But I would actually recommend, if you wanted to do something like this and make a little like light on a wall kind of thing, right? You can stick some double-sided tape on the back. I would just plug it into a regular like phone charger outlet. Those little phone blocks, just run a USB cable to that. And you could run this anywhere. That's what's nice about USB power, right? Is that nowadays we all have a bunch of those little USB friendly, like charger blocks everywhere, right? I feel like I have like 10 or 12 in the house. But anyways, so I hacked this to work with my regular TV remote. I am not running this off of a remote, like, okay, literally like this says Samsung on it, right? This is my actual TV remote. What do you think? How did I actually make this work? I want you to just guess. I know you don't have any reason to know this, but just, take a stab at it. What do we know about products you maybe did with Arduino during build-alongs? Think about what we've done before with sensors and the serial monitor, for example. How do you think I was able to figure out the values of the digits on my remote and create a project built around infrared? Any thoughts? It's not as hard as it sounds. I do want to clarify that. Like, I know I probably am gonna sound like I'm maybe being a little dismissive of the work involved when I say like, oh, anybody can do this. But truly, it is out there. If you want to find out how any device can interface with infrared, this just happens to be a device that has infrared built in. That it's not like other devices where you might have to add it physically. That it's actually like a built-in feature. So infrared serial monitor. Rihanna suggested you might be able to see something with the remote, right, itself. You know, talking about the different light sensors. Yeah, so the trick is you have to go ahead and generate basically, you know, infrared readings, not infrared readings, sorry, readings from your device and put them into like a mode that you can see, right? So give me 1 second here. I'm gonna switch this over. I wanna show you it on my computer screen and before I go on to the next thing. So give me 1 second. So this is one of those things where I teach off of a Mac usually, but this thing seems to really like being on Windows over being on a Mac. So give me 1 second if I can get this little guy to cooperate so I can show you. Perfect. All right. So I have for you a little visual of the codes that show up when you hit this with your remote. Okay, so you're gonna have to just excuse me for 1 second as I get my screen share going here. And I'm going to let you see the results on my screen. All right, so this is a Python-based application I did. I actually am a Python teacher, so I do Python a lot. So do you see the readout there? There's 4 digits, 31, 31, 31, 31, 223, 32, right? That's when I hit number 1 on my remote. When I hit 2, it's 31, 31, 95, 160. When I hit 3, 31, 31, 159, 96. What's going on here? There's a 4-digit like key associated with each button, right? And all I did, I went and hit 5, 6, 7, 8, 9, and 0, right? Is I took this list, all right? Let me go ahead and get my color remote program up here. Here, let me do this little different way to get this open, show you. All I did was I mapped those to different colors, right? So you get the idea here, right? That like there are literally a, you know, numeric piece of data being broadcast by an infrared device. Now, let me go ahead. I don't want to get too deep into this Python code because we're not going to actually use that. I'm going to go back to my slides here and I want to show you where this connects. All right. So how does a robot make use of this? So this is the sensor as it will be mounted in your robot. And it's broadcasting a specific infrared signal. Because there's infrared out there, no matter what you do, right? Infrared's out there. Different things generate infrared. Candles are a great example of something that generates infrared. You know, certain infrared light bulbs, like what's in our TV remote, right? So what we have for a robot is actually we're emitting an infrared signal, specific signal from an LED that then bounces off of a reflective surface on the wheel and then is picked up by what's considered a phototransistor. It's like the opposite direction, right? So one side is emitting a signal, the other side's picking up the signal, right? And that's essentially what we accomplish, right? What does this mean for programming a robot? If you have the ability to count wheel rotations, what does that give you in terms of like, what can you do with this kind of data? So we're going to use infrared to broadcast a signal that then bounces back, right? And then is something that we can, you know, determine, right? So go ahead and give me a guess. What do you think? What would be useful to knowing wheel rotations? This many rotations, right, equals, let's say, 18 inches. You know, 10 rotations equals 18 inches, right?
Or if like you know the inches of the circumference, and you know like if you go 20 inches, it's gonna fall down the stairs.
So what does Roomba do, right? Roomba has like a sensor that it can detect when it hits a ledge or when it hits a wall, right?
Yeah.
Roomba basically creates, like, if you sat down on graph paper, right, and went forward 5 steps and hit a wall, you'd go up 5 blocks, mark X, that's wall. Go back to your known location, go over 1 and up 5, and then oops, there's wall again. Now you can map where all the wall is because you can count how many steps you took, right? Same idea. You can map where you've been, right? If you can count how far you've gone, right? That's a really common application of robotics, right? That's why we should always gather data about wheel rotation. It allows us to do also control the distance, which Edgar pointed out. Allows us to control distance, allows us to count distance till another sensor is triggered, and it allows us to specify a distance. So if you have, let's say, a job at NASA, and they say, here's our satellite image, this is where the robot rover is going to land. We need to navigate this terrain. It's this distance till this, turn in the path, and then this distance. You know the wheel rotations, right? And you can apply that. Now, tell me something here. Are there some motors where it's built in that you can specify the rotation, and there are some that you cannot? Does anybody know this about different types of motors? Here, I'm gonna turn off my webcam here, and I'm gonna go ahead and grab some motors out of my sort of hobby stuff. I'm still on the mic with you. Shout out to me, folks. What do you know about motors? Anybody know? We'll talk about this on another day. I'm just gonna leave this a little teaser for you. But there are different types of motors in the world. Oh, this is a perfect example. Let me go ahead and stop my screen share so you can see me nice and big. The motors on a 3D printer, for example, right, have built-in basically degrees of rotation, and you actually tell a 3D printer. This is a little DIY 3D printer, by the way. This is the bed here in the front. Right, this upper portion here is for carrying the head. And so basically, when the motor spins to move this bed, right, it knows how many rotations of that motor correspond to how many millimeters, right? So anyways, those motors know their distance. This is a type of motor called a DC motor. We'll learn more about DC motors another day. But DC motors, they don't have calculated rotation. So you have to use a sensor to identify them. So this is straight out of the robot kit, by the way. So, all right, so let me tell you one last thing about infrared, and then we're gonna do like a little get to know you thing before I let you go for the day, so that we have a little bit of familiarity with our peers. All right, so Nintendo Wii, I told you, uses infrared to communicate, right? That sensor bar on Nintendo Wii, I always thought, by the way, Nintendo Wii came out when I was like much younger, right? It's been a lot of years since Nintendo Wii. I thought that sensor bar got the signals from your controller, right? That what you hit, that sensor bar picked up. Because they call it a sensor bar, right? That's false. That sensor bar does not send any information to the console at all. That sensor bar simply shoots out an infrared signal to the remote. The remote sends the communication. Interesting, right? Hey, somebody's got the Nintendo Wii remote. All right. Well, you can try this experience at home, okay, Mimi? This is an interesting little thing here. Your sensor bar just broadcasts infrared. That's all it does. That's all it's for. So what does that mean? That means put a blanket or a towel over your sensor bar. Make sure there's enough space in front of your TV, by the way. You don't want to melt your TV. Light a candle in front of where your sensor bar would be. Make sure the flame is good and exposed. Don't light a jar candle where it's way down and it's going to be blocked how much light is coming from that candle. But if you light a little candle in the space where your sensor bar is, and you turn on your Nintendo Wii, cover the sensor bar from the Wii with a towel so that no light's coming from it, you can actually send you can get communication. It's not going to be as good because the candle's not going to be as strong of a infrared signal, but it actually will blanket your room with infrared, and you can communicate with the basically infrared source of a candle the same way as the infrared Wii sensor. Is that pretty wild? I didn't believe this when I first heard this. I had to try it just to know for sure. And I have a great story for you here on this one. I have a replacement Nintendo Wii sensor. I'm gonna go grab this. It's just over here, like literally 2 steps away from me. I'm gonna turn on my video. I have a replacement Nintendo Wii sensor that does not use the Nintendo Wii for the power. See if I can get this out of here to show you. All right, not as simple as I thought. I'll show you next week. They make USB powered ones that you can just plug them in, and it doesn't have to plug into the Nintendo. You can like plug it into the wall. I went to like untangle it from everything else, and I was like, oh, I'm really bad at cable management behind my TV. So that's a lie. I'm not gonna go grab it. You know. So anyways, but I'll show you next week, or not next week, 2 weeks from now. It's just they make USB powered ones that don't plug into the Nintendo Wii at all. You just plug them into an outlet and it still works. So if you want to try that, it's a fun little like, hey, who knew? All right, so we have a couple minutes before you go. And you know, this crowd of people here, right, is not the same as build-alongs. Build-alongs happen many different hours throughout the week, right? This group, everybody's got the same kit, and everybody's got only one time choice, right? There's not like a bunch of us, right? So I'm gonna throw out a little bit of suggestion here, right? That if you want to share something about yourself in the chat or on the mic, get to know some of your peers here today. You know, as we get into the last few minutes of the time we have today, I encourage you, you'll have more fun if you feel like you know somebody. You know, that's part of the thrill of like class as a group, right? Otherwise, you would just watch recordings of class, right? So you want to share where you're from, and then I came up with a bunch of like other suggestions. You can make your own plan, which was things like what's your favorite cereal. There's been a lot of Lucky Charms in my house lately, so you know I thought I would throw in something like that. What's your favorite school subject? What do you like more, coding or building things? Rowan mentioned about you love Legos. I love Legos too. So maybe you like to build things. What's your favorite video game? What's your favorite math constant? The answer is always pi, right? But anyways, you know, if there's anything you want to share, take a few minutes. You don't need me talking over you. Go ahead, have a couple minutes, get a chance to say hello to some folks. I'm gonna probably just turn off my mic so I don't interrupt you, but get a chance to know some people.
Hey, Joel, I think you're muted.
No, yeah, I did that so the kids could have a chance to do a little bit of without me.
Okay.
Over them. I didn't want to, you know, make them feel like they had to say hi to each other with me. You know, giving them
cool.
Right, you know. So, but hey, do you want to tell us? How about you tell us something about you, Oscar? What's your favorite cereal? I talked about Lucky Charms already.
I think mine is Honey Bunches of Oats.
Okay, yeah, I've gotten that plenty. What else? Any favorite school subject, or what's your favorite video game? Favorite math constant? Mine is pi. Big surprise.
I was definitely a math nerd in school.
So what's funny is that I look back at like math now, and I think of myself like, you know, at the time I didn't think I was like super into math. It was only after that I was out of school that I recognized like, oh, I really love math. You know, oh, Brianna mentions linear algebra over my head. I'm sorry, I can't compete now. So life cereal gotta mention. I'm impressed. All right, so Oscar, I'm gonna go ahead and turn it over to you for the, you know, like wrap up here while I go and look to see if I can show everybody this Nintendo Wii sensor. They actually make a third-party one that doesn't require power from the console. And I have one, but it's very to detach it. So I think I can get it if you give me like 30 seconds.
Yeah, go ahead. Yeah, and so today was more of an introduction, since we're all gonna be together while we're building the Wi-Fi robot. The next few weeks, we're gonna be actually building hardcore assembly and programming it. So it will be more more hands-on, but also keep in mind we also want to make sure you're learning the theory and an actual lesson on the different parts, right? Because if you're just putting the robot together but you're not really sure what you're doing, it's like, what's the point? So we want to make sure that you're understanding every part of the way while you're building the robot. So
here it is, folks. It is a USB powered infrared IR blaster, basically, right? That it's just the same thing as what was on the Nintendo Wii, but you can use it for anything, right? If you plug it in, it just starts broadcasting infrared. And so this is how you can actually, so the reason why I have one of these, in case anybody out there is like, yeah, but like, what other things work with infrared? I've actually configured my Nintendo Wii remote to work on a regular computer. So you plug in power on one end, and then you can basically, there's like tools to install to make your Nintendo Wii remote work like a computer mouse. So for anybody out there who's ever said like, you know, yeah, can I do anything? So Brianna, you might not realize that only went to me. You said something about, did Xbox make something like that too? They had the Kinect was their device, and Kinect was a camera tracking thing.
Okay, that makes more sense.
Yeah. So if I ever seem like I talk a lot about video game hardware, I actually think that video game hardware is one of the best examples of creative ways to apply different tech. For example, like there's a lot of things that we don't ever stop and ask, like, how does a game controller have rumble effects or things like that? And like when you look to see how clever the solution was to make a video game controller feel like it's shaking in your hand, it's really just a weighted motor is all that's in there. You just look and you're like, this is so impressive. Arcade technology is another great example, like pinball games and all kinds of stuff. Amazing electrical engineering, right? How many times in your life though do you get to see the electrical engineering of, like, let's say the internal workings of a car? Not as easy, but you can take apart your Xbox controller and see right now how those things are configured, right? So fascinating stuff. If you never really took a moment to stop and wonder, how do your video game systems work? How do different electronics, consumer electronics work? Fascinating things. So we'll keep, you know, sneaking in different examples. They're like universal concepts. Where it is, like I said, we'll talk more about motors another day, but I kind of gave you a little bit of a teaser. There's different types of motors. There's a reason why tracking motor rotations is key. We'll talk about other hardware. If there's anything that people are interested in that like we maybe didn't talk about one day and you want to like mention, and we can, you know, plan for it on another day, you know, don't hesitate to share your interests or your curiosities. I see Rihanna mentioned about wanting to get a 3D printer. You know, I would recommend, don't encourage me to start telling you about all my favorite 3D printers, because that is a long list. So I got a lot of 3D printers in my house. My latest one I got over the winter break in December, and I've been printing stuff in the garage because it's one of those liquid resin ones I told you about that uses UV light to cure the plastic, and so it's a little bit more messy than regular 3D printers. But anyways, so yeah, hopefully you got a chance. If you didn't know myself or Oscar, hopefully today you got a chance to get to know a little bit about us. So we'll be the people here for these sessions, and it's nice to see some people share you know, some cool little details in the chat. I wasn't even expecting that Kinect comment got some extra traction here about like, Charlie, that's great that your dad's got a story about seeing an early prototype of it. And I can remember before it came out that like there were like demo videos of what Microsoft was working on. It's fascinating stuff. And, you know, I see some mention here, folks who got their own YouTube channel and other great stuff. So hopefully you felt like you got a chance to learn a little bit about your peers. And also got a chance to share a little about yourself. If you're somebody who's, you know, a little shy or you know, patient to share about yourself, that's perfectly fine. We'll be together again. You didn't have to share something today. We don't want to make you uncomfortable. Whatever, you know, level you want to share, that's up to you. And we'll let you go at that point, and we'll look forward to seeing you again. Okay, folks?
Bye.
Thank you so much. You guys have a great night.
Bye.
You too. Thanks.